thing, kind of move it up or down, and then kind of 360.
I'm right here.
Okay. Hey.
So how is that going? Like, where are you guys? You're developing something robotic? Is that what I understand?
It's not okay. Let me share my screen and
Okay.
see what we're working with. I don't know if you can see my screen right now.
Yes.
Okay, so this is like a prototype. So the idea is to have a very stable device like this. At the same time, that it's going to be lightweight and with some adjustments. So the joints, which is like right here, it can go either way, up, down, and at the same time, it can go 360 this part. That way you can turn the, so we're trying to put the eye gaze device on one side and the iPad on the other side. That way you can like twist it 360 on this side. So these joints is where we're really going to be working with the engineers to make it very stable. So it doesn't like, because what we have in the market right now is the gooseneck kind of thing. It's not stable. And the joints are not really meant for movements. It's kind of stable. But for Ash, we want him to be able to like move the wheelchair and still have some stability with it. So right now we're thinking about some, the question we want to ask you guys is if you guys can recommend some kind of materials that we can use that's going to be lightweight and strong, durable, and all of that. Although we still have plans on talking to the engineers about that.
My question is, what kind of eye gaze device and how much does that weigh?
We don't know specifically what the eye gaze device is, but they did mention that it was bulky and heavy.
Tobii Dynavoxes are around 18 pounds.
Right, and that's, yeah.
Eye gaze Tobii Dynavoxes are around 18 pounds, unless they've gotten significantly trimmer since I last used one.
Even if they're a little bit lighter, they're going to be at least 15 is my guess. And then you've got a couple of pounds. The iPad probably has a case on it. So it's going to be, you know, what, at least 3? So we're up close to about 20 pounds. Yeah, I would say the engineers would have a lot to say about that.
Yeah. So
I'm just gonna jump in here quick. I'm not part of the student group, but I do know that the new Tobii Dynavox setup on the they have a new one on the iPad, and that is much lighter. So it may be something that you want to find out exactly what device the student is using. I just trialed an iPad one with a student, and it's much lighter than the original Tobii Dynavox.
Is that the pilot?
No, it's out now for students to get.
You can put their eye gaze bar on an iPad.
Yeah, it is it's the Tobii Dynavox Pilot. It's the name of the system. Yeah.
So
That's the name that Cash is using?
No, I think they're not sure of the exact model of the
Sorry.
Dynavox. So it sounds like maybe SY, Emily, and Kanani need to check with the family to find out which model of Dynavox they have, and even how long they've had it, because if this is the newest version and he's had it for a while, he probably has a little bit older one.
I know.
Referred to my notes, I think it is the Tubi, and he's been using it for I think 8 months, so he's still practicing, learning how to get familiar with it. He uses the iPad way more.
I know they mentioned that the device is kind of heavy, so that's what they're having problem with. So regardless of the version that they have, it's kind of heavy.
Right, and that's going to make this design particularly challenging, I would think.
Yes,
Creating that joint, both of them, that your connection point and your joint would, I would think, have a lot of stress on them.
yes. That's why we're considering carbon fiber pipes. They are lightweight and they can hold a lot of weight, and it's not that expensive. But we're still gonna see with the engineers what they would say about it.
Right.
One of
Yeah.
our Shark Tank judges for next week is a rehabilitation engineer. So Dr. Ding will be joining us next week during the presentation, so she may have some suggestions too.
Mhm. Yeah, so for the joints, we want a situation where we can hold it in place with something like this. Yeah. We don't want the degree of freedom around the joints. We want it to be like as close to 0 as possible. And it's just gonna be like, so it's not like multi-joints, just to achieve stabilities.
Kanani,
Oh,
I think I
and,
heard you say that you know that he has a Tobii Dynavox, but there are various models of the Tobii Dynavox. So it might be useful to find out what model and then be able to find out the weight.
Okay, we can do that.
And this is our initials right there.
It's a great drawing.
So that's what we have. So for this right here, this is gonna be like the panel that's gonna be on this side. So it's gonna be 2 of these, one on each side, one for the Dynaverse and one for the iPad.
Yeah, it's a great design. You're entirely beholden to your engineers here. The joints are going to be the critical part. Any material, there are lots of materials that are light and strong enough for the arms of this. They should be able to do the math on the physics pretty quickly on how strong those joints need to be, but finding the mechanism that's easy to use and provides the resistance that those joints need to be stable, especially if the chair is in motion, is going to be tricky. So as long as you have good engineers, I think it's possible.
And how, what's the plan for changing the angle, or will that be, I mean, like, will it have to push something and then it will?
Okay,
be
so
movable?
it's gonna be from the base. That's this diagram right here. So with this right here, you can push it away and push it towards you, but it's gonna be at the base side. So it's gonna be.
So the angle joint is stable.
Yes,
it's
it's
that-
very stable.
Okay, okay.
Mhm.
And Ken is writing in that there's lots of commercial options, and have you looked at those and everything else,
Yes,
how they're?
yes. So we looked at it, and what we find out was that they are very not customizable. Like for this, for example, it can go up in length right here. So most of them is just like fixed. You have just a fixed length. So if you want to like increase the height, is not possible with many things that is in the market, except the gooseneck type that you kind of like straighten up, and it's not stable at all because there are multiple joints. You know. So because most of those are created with the idea of just having you access the device. But for this, we are trying to achieve stability and the ability to like change from iPad to the device. And for the charging part, the cable is going to be like inside. We're going to use a conventional standard charging. If it's using a power wheelchair, you can connect it to the wheelchair, and it can also be connected to electric, outlets. So that's going to be a simple add-on to put on.
So I think I'm gonna just play the danger game a little bit. So if your bottom arm raises up and
Yes.
you've got an 18-pound, let's just say, device on the top, and you want this guy to be able, this 12-year-old, to be able to move his wheelchair with these devices attached.
Yes.
This is his voice. If this is raised up, even if you tell him, don't ever drive with this device elevated, if anything happens to his communication device, you are in effect taking away his voice. And so structuring this so that when it's raised up, that nothing will happen to that device, I think is really something to consider. It's a lot of weight that's hanging up at an angle, and it's a real, I mean, not that the iPad is anything, you know, cost-wise to ignore, but Tobii Dynavox eye gaze devices are super expensive. I mean, you know, covered by insurance, I'm sure, but I just want to say
Yes.
that.
Yeah,
Some of the things that I think I'm not the only one thinking this.
so we have that in consideration. And so these are going to be pipes, and we have contingency plan. The pipe is going to be double on the part that raises up. So it's not just going to raise up and going to be a single pipe. So it's just like a walker that has another one inside when you like extend it. And it's only going to go half of the original length. So it's the full length. It's not going to go like 100% high. The highest it can go is 50%. So there's still enough pipes on both sides that is holding it. So
Okay. Yeah, I'm glad that you're thinking like that. I like the idea of the double pipes.
and we looked into the carbon fibers. A 8 feet carbon fiber weighs less than half a pound. And that's all we need, 8 feet for one device.
Yeah, that is not the weight that I think is too significant. It's great that it weighs next to nothing,
Yeah.
but an angled 20 pounds of equipment, all that stress on that joint seems significant.
Yes. That's why we would say that the joint is a part that we're actually going to be working on.
Yeah.
Very well with the engineers.
And you couldn't find anything commercially that
No.
Oh, because of the double or because of the adjustment or both?
The stability.
Oh. All right. Well, it's quite a task you have in front of you. Let me see. Okay. I'm just checking the chat. So Ken, anything else to add in? Anybody else? Any comments on this project?
So I've been side chatting with Lori, and yeah, I just generally to say that there are engineers out there working for companies like Daisy who spent their careers designing devices like this for, you know, to be as low cost and as high functional and safe as possible. I just can't imagine you guys pulling this off in the time you have. So it's just a concern.
We have great engineering.
Yeah, you have great engineering students.
Yeah, the only thing I would say is if this project moves forward, to make sure you test this with cash, with, 20 pounds of not communication device, just to make sure it's really, really functional for him before you put his $12,000 communication device on there.
$18,000.
We may have to test it with a local person. So Cash actually lives in California.
Okay.
But we do have another user or partner who is a Dynavox user, Becca. So we might be able to have Becca test it for us with her Dynavox if it's a similar model or about the same weight, who's also a power wheelchair user.
Or a milk jug filled with
Water,
rocks.
8
Yeah.
pounds,
Yeah.
8 pounds of water per milk jug.
Yeah.
Just a side note on, I've done a lot of Dynavox eye gaze systems over the years, and the points that they fail at is in the joint and the higher you make them. All right. I do know that we have used double bars to strengthen the bottom bar, okay, to help distribute that weight a little better. Just an idea.
Right, and Shannon is adding in to see if you guys have reached out to Tobii Dynavox or to your state AT program, just to see how, what they have and how it works, and even just to try it out with weight, to see what you would be trying to do differently.
So SY, Emily and Kanani, if this one does move forward, we do have that relationship and the ability to work with Tech Access of Rhode Island. The eye gaze that you guys got to try out when we went for the visit, that's a Tobii Dynavox. So there's a possibility for that.
And I would say, if for some reason this doesn't move forward, keep in mind that Tobii Dynavox is making new devices. Cash at some point would probably be eligible for a lighter device, which would then decrease the pressure on these joints and maybe make a new design more possible, more plausible. So, even if it doesn't move forward, it doesn't mean that to give up, because things are always changing. All right.
Thank you.
Yeah.
Thank you.
All right. Well, thank you, Team Cash. Who would like to go next? Do we have somebody that's interested from Team Yui?
I can share a little bit. So we essentially have designed a like self-feeding device. Let me see. I don't know if I have a picture of it because the person. Sorry, one second. Oh, we have the picture. Okay. And so essentially we kind of determined that with Yui that he was most focused on being able to self-feed using a spoon, because he doesn't really have the ability to do that. He usually uses finger foods, like that are diced into small pieces, or a fork. So we kind of come up with like a trio spoon option that has a deeper bowl so that it can contain liquids. We came up with like a magnetic lid so that it prevents or helps prevent spillage, with a little divot in it to allow for eating. So if there are liquids in it. And then we have a meeting with him afterwards to actually show him how he feeds, but we have 3 different handle options so that, like, based off of his like fine motor grasp and function, if one day it's better than others, or if there's something that he prefers, then we have a built-up handle grip, a T-grip, and then like a clasp over the hand grip. They're all magnetic, so with the idea that hopefully we want him to be as independent as possible. So that's his goal, so that if he's able to change it out with the magnetic feature, then that's what we kind of have going on.
All right.
I don't know if Sinclair wants to add anything, but that's kind
Have
of,
you tested that with the weight of the food that the magnet doesn't separate?
this is just a rough draft. We don't
Okay.
have any sort of,
Okay, just
prototype yet.
just a note.
Yeah.
Yeah.
And do you know what kind of magnets and their strength? Not yet.
No, this is very like preliminary rough draft, just concept. But they did say that we could potentially 3D print something, so I'm not sure like what type of material it uses. So that's kind of where we're at. This was just like, he wants to be able to like use a spoon and like eat foods that are maybe softer, or it could like soup or stuff like that. So we were kind of trying to make it as self-facilitated as possible.
Sure.
try any different
And
options.
he would then tip this into his mouth, that he has that action.
So the actual like stalk of the spoon, I guess, or like it's like a material that can be bent. So if there is, again, we have a meeting with him afterwards to see what his, like if there's supination, or if he, but I know he is able to bring food to his mouth because he just isn't able to use a spoon. So I don't know if it's like a spillage problem. We're gonna ask further questions.
Because he
Sure.
currently uses a U cuff. When he uses a fork, he has a U cuff to help him. So we were thinking if we gave him additional supports that he would be able to use a spoon too.
So I guess the question is if he's successful with the U cuff, how come you haven't designed anything like that for his spoon?
That's a great question. That's honestly a great question.
And have you ever looked at the sup spoon? Have you seen that? It's commercially available. It's SUP, but there's an apostrophe after the S.
Yes, that's on one of our like, it's part of like what we pulled off of like competition from the market. Yeah.
Right, and it sounds like he would need some kind of handle modification for sure.
It's
Yeah,
more like,
go ahead.
sorry, I just wasn't, so like the sup spoon, I guess is, I don't know the material of it. So we're trying to kind of see if we can make like the actual part bendable. So if he does need help, maybe having it like turned, that part can be turned a little bit, like a curved spoon. So kind of making it to where it's adjustable.
Mhm.
So that was kind of, yeah. Any other suggestions are appreciated, so.
Yes, they are.
When you meet with him this afternoon, make sure, tactfully ask if magnets would interfere with any medical devices he may have. For example, we have a gentleman here who has a pacemaker implanted to stop his seizuring, and they use a magnet to activate that. Just a note.
Consideration, yes.
Thank you.
I do want to compliment, there are a couple of really clever aspects to this design. Whether they're right for your particular person or not, that's, that remains to be seen. But the detachable lid on the spoon is really clever. I can see that being really useful. And if I'm interpreting this right, I'm not sure, from the drawings you have here, those magnetic connections, the lines almost make it look like those have teeth, almost like a gear to help keep them in orientation, locked in orientation, so it doesn't twist. And if that's true, then that also lets you orient those 360 degrees anyway to line up the handle with the spoon direction, that axial rotation that you can lock in as you flip it into place. I'm not sure if that's what you're trying to illustrate here, but claim it. And that's really clever.
I think it's excellent idea, and you can change it out for so many different things.
Oh, yeah.
The whole, if the system works, you can do all kinds of different implements to improve someone's life. A brush, a toothbrush, a pointing stick, all those good things.
Yeah, I was gonna
Ideas,
say
guys.
the same thing, you guys. It has like a modular design almost, right? So you can interact with it in different ways. And as you mentioned, if the person's function may vary throughout the day, they can then adapt the device to fit their needs, which was very clever, and also increases it to work just beyond this specific individual. I do know him pretty well. I spent a lot of time working with him in his home, and I think that it will work for him. I really do.
Can you say a little more about how the lid will work? Is that something that is during the scooping process? Is it there at that time? How does it work? And is it only for you have a small notch in it. Is it only for thin soups?
So I guess that's a good question too. Yeah, the idea of it is, I guess, to like prevent spilling. So it would not really make sense to have to take it on and off every time that you're going to put liquid in it. But if you can just if the ability is there to just very, very thin liquids and have that small amount be able to just have it seep through so that it can just then already be in there and prevent spilling.
Okay.
If that makes sense.
Yeah, it does.
Okay.
Yeah, you could even, I mean, depending on how easy or difficult it is to make pieces, you could have a lid that would be half, and this lid that has just a small notch for a broth soup or something. But you could have varying, and find out what's most useful for him, varying lids.
I know we talked with a previous group about material questions when it comes to anything that's going to go into the mouth, and that 3D printing is generally thought of as not being appropriate for anything that goes into the mouth. But that it is good for rapid prototyping. So this absolutely could be, that could be where you start. I have not thoroughly read it, but a paper did just come out that looked at hand washing and sanitization of 3D printed parts and measured by surgical technicians with petri dish cultures and everything else to see if they were safe, and reached the conclusion that it actually was safe and that they could be adequately washed to be used in the mouth. Not saying take that as gospel and go with it. Haven't read the paper thoroughly, but it might not be as bad as we all thought.
I was just going to comment the type of food that I would see this being most useful for, because if you just had pure broth, you would use a straw, right? Just drink your broth, right? But let's say you have a soup, like a vegetable soup that has both noodles and small pieces of food, that you start off with using just the typical spoon, but then you can't get all the broth, right? And that's an issue, and you would need someone to assist you. He will be able to just take and put the little lid on, the magnetic lid on, and be able to finish his soup without having to transfer it into something else.
Or you could get out a straw.
I think we also were thinking in terms of soft foods too. So it doesn't necessarily I don't know, mashed potatoes or any sort of just softer textured food that you wouldn't even need the lid necessarily. So it's just a multifunctional spoon, but with the option of having a lid for liquid.
So my concern with something like mashed potatoes is it seems really deep. It seems like it would be hard to empty a spoon that is so deep. And I'm not saying, he could probably eat mashed potatoes with a fork, and there's lots of food out there. But that was just what I pulled off the top of my head, but something that was but I get what you're saying, absolutely.
And that's where the prototyping comes in, and the 3D printing as an easy way to prototype.
Right, and just add the fork attachment. So the other thought I have, if the magnets are strong enough to hold, does he have the strength to change them? That's something to look at as well. What would he be able to, or what would a person be able to do and still have it be functional to hold up to eat?
Yeah, so initially for like the magnet lid, we had it as a clip-on. And then we were like, well, we want to, again, like if there is the ability for him to do it himself, a magnet might be a little bit more functional. So that's kind of why we went from a clip-on to a magnet.
Mhm.
But I'm not sure what your thought process is on that, maybe.
But yeah, and I think the lid is the easier part. The handles where he would be holding would be the part where the magnet could come apart. Either the magnet could come apart while he's eating, or he wouldn't be able to independently switch them out. Now, you know, it's going to work for some and not for others is my guess. But that's what comes to my mind. But I do like the idea of the teeth, because that is probably going to add strength. And then maybe, I don't know.
Yeah.
I don't know.
He's not weak. He just has very limited motor control. And so when I saw the magnet, I thought, well, that's excellent, because think of chargers for electronic devices. A lot of people are not able to get it to line up to place that in, but if you have a magnetic charger, it sort of sucks it to it right to where it's supposed to be. And so that alignment happens as a result of the magnetic pull, rather than the person needing to be able to have it perfectly lined up.
Yeah. All right. Any other comments? I think there was. Yeah, Ken is just writing. You know, there could be a fork and a spoon, and you just choose your implement. Yeah. Sounds like an interesting one for sure. Thanks. Thanks, everybody. All right. Who wants to go next? Anybody else want to talk about their project? Don't be shy. Otherwise, we're move on. Nobody else? Everybody else is solid? Okay, so that means Team Becca is good. Team Fred, Team Casper, and Team Mitch, and Team Jonathan. All are heading in their direction and ready to roll. Okay. Okay, so Casper is good. Nice. All right. So I am curious. I gotta find the guy. Oh,
Is it Mitch?
Yeah. I am curious about Team Mitch. If you don't mind telling us what your plan is right now.
So we updated Mitch based on our discussion last week. He does not want it to be on an ivy pole, or like we even proposed a coat rack. He wants it attached to the wall. So we're going back that route, trying to use one of those adapt, I don't know what it's called, but that thing that goes on the wall with like a hinge. And he wants it to be able to go like flush against the wall to be put away. So I think that's what we're working on. That might just be a piece that we can buy off online. And then the piece itself that we make, he said to focus on just a knit hat. So our prototype will be the skeleton and then something like that to put it on. He didn't really go for the sunglasses idea, even though
All right.
that seemed like the easiest to drive into, but we are still not totally sure about how the hat will be put on. It's kind of something that he can move around into. He agreed that the robot on his head would be dangerous, so something static. He agreed to that, so we're working on that.
Great. Great. Sounds like you've got a more focused direction to go with him, which is great.
Just to add to it, we were talking about for the skeleton, I think one of you guys had recommended it, but we were even thinking either like some sort of button or switch he could hit to release the hat, like if it was clipped in or there was a magnet or something, or like he said that he has some control with his thumb, I think, and so like some sort of switch that he could control with that. The other thing that we had previously talked about in my group is something that maybe he could like either pull down with his chin or his mouth, like some sort of like string or lever that he could pull down, and then his wife would just have to reload the device like when he's done wearing the hat. But yeah, that was the only other thought we had.
Yeah, it's unfortunate that he's chosen the floppiest of headwear and stretchiest of headwear. So that just makes it much more difficult to get it on his head.
Yes, that's what we're struggling with, but
Which is probably why he wants you guys to figure this out, because it's hard.
yeah.
Yeah, it's nice that he's willing to use his mouth to, pull something.
I also think it's nice, Scott, that he's giving real feedback, including, yeah, I don't want that approach. That you often don't get that when somebody's volunteering to help.
He also has an engineering background himself, which is helpful.
Oh, then nothing will work.
No, that's great. I don't know what else to say, but I wish you luck on this one. I'm sure there will be a few of us that roll that around in our brains for the rest of the day. And as some of you know, I'm not shy to shoot something off if I think of some wacky idea.
Yes, please do if you have any thoughts during the day.
Yeah, so I will say that if anybody who's just joining does have an idea later on, feel free to email Naomi or I, and we can pass that along to Andrea. Just any kind of passing thoughts, whether it's something that teams can use or not. All right, so thank you for that update on
Thank you.
that was Mitch. Yeah, and then yeah, I can somebody remind me what Jonathan wants? I didn't make a note of that. Like what's the team working on?
Jonathan wants to be able to flick his friends. He doesn't have the last joint.
Okay.
Yeah.
I love that. That is actually maybe my favorite.
Students on that team, could you share what you found that wasn't commercially available, which I was very surprised existed?
Yeah, there's a it's on, I think we found it on Amazon, but it's a power flicker for your hand, and you can do either one finger or you can do multiple attachments, but it's made with very heavy duty steel, and you can break bottles with it. They say it can be a self-defense mechanism. I would say, I don't know if that's gonna,
It's called the O-Tone Tricky tool, I think.
Yeah.
Can you put the name of it in the chat? Oh, yeah. Wow.
It's a very heavy duty and yeah, it's $23.99.
But some of we were talking about maybe some of the design features, even though the material itself sounds very dangerous, and we want to avoid that. We don't want him to be maiming his friends when he's flicking them, but some of the design features might be helpful from it.
Absolutely. I love that. All right. And then, oh, and Fred wants to be able to transfer, correct? That was the main goal for Team Fred, was just the transfer. Is that correct? Okay. With no car modifications. All right. Well, good luck. Okay. And what did Becca want again?
We are doing a call button, like an emergency call button for when she leaves her house and is not near any of her caregivers, or going to her friend's house. She's also about to move into her own apartment too.
All right. Well, I think it would be great. So we've done a couple of these roundtables with a lot of you students, and then so we have the kind of the judging, and then what comes after that. I think it would be great if at some point we could do a follow-up where you guys join, or at least a representative from each team could join a roundtable and kind of update anybody who's interested on what happened. Because this has been really interesting. I think the whole process of like, here's this big idea and here's what we're really going to come down to do, or we thought we were starting here but we're ending up there. It is a process that I would say most of us have gone through at some point or another with any project, but I will have the honor of seeing some of these and probably hearing about some next steps, but I would just encourage each team to join us, and maybe Andrea can encourage that a little more than
Yeah, I can definitely help facilitate that. And they'll be working with another instructor during the springtime too, Dr. Dawes. Monique will be doing a course with the students who move forward with their project design. We have a budget to create these products. So we can't go past our budget. But luckily a lot of them I think will be able to be created pretty inexpensively as prototypes anyway. And the involvement of the students from our engineering and design programs will also happen during the spring semester. So, and finally, we have a university-wide Shark Tank, what they call Shark Fest here. And so some of the students may find that their idea moves into that even, which can come along with larger prizes to help commercialize it. So it's pretty exciting.
That is very exciting. I hope that at least one team will move into that school of sharks. All right. So thank you all for all of those updates. And does anybody else have any current problems that you want to throw out to the group? Anything anybody's working on? Laura, you got anything cooking? All right. Shannon, anything
There's always something cooking, Scott. It's just not ready to go anywhere yet.
Yes. Now, well, I'm glad you joined us today, Shannon. It's nice to have you here. All right, well, let's see. The things I've been working on are kind of dull. I just made a different scanning station for OCR. I got my windfall of corrugated, plastic corrugated cardboard, whatever that's, plastic board. And so I've just been able to do a few things with that. Which has been kind of fun. And Ken, anything on your end?
Well, you already know that I'm planning to pull together a set of people, you being one of them, probably in early or mid-January, to talk about the feasibility and vision for an AT Maker conference.
Yeah, so this is something that, there have been a few things specifically designed for makers, and most of them are either like makers making change, like a hackathon, or kind of a one-day event that is really heavily focused on actually the make and take. With some things like at ATIA, there's information, but Ken is interested in having a more conference type event where we have sessions where we talk about things as opposed to just like getting together and doing the rapid prototyping, or walking away with a bunch of little things made out of wiki sticks and PVC. Correct, Ken? I mean, correct me if I'm wrong, but you're looking at like a full day or a 2-day conference that is geared towards making.
Right. I'm focused on the process more than the result. And getting people on the right path to produce devices that are usable and widely distributed.
Yeah. Yeah, so that is in progress. So anybody who's interested in having something to say about that, let Ken or I know. And then just, keep your ears open if you're interested. Shannon, you put something in the chat that says lithophanes are fun. What are those?
Oh my gosh, my daughter's friend, I have all these young creative friends. He's been making, well, he's been doing their family photos for his friends and stuff using this open source lithophane site. Yeah, Ken's got one right there.
But what is it?
So look at that.
Okay.
Was that 3D printed?
Yeah, it's 3D printed. And I just
That's
use,
cool.
I think I use PETG, but PLA works, and it's controls. It creates images by changing the density of the material that the light has to pass through.
Wow.
And it's amazing, I think.
I do too. It's kind of like fun. So just another whole thing to explore.
Yeah. Huh.
There's a, let me see if do you have the
There's a
website?
website.
Let me see.
Hey, Ken, would you mind throwing your email in the chat? Because Mary Lee is asking how would she keep up to date on the conference if there is a maker conference? And I think you at this point are the point person. Thank you, Shannon. We'll have to check that out. It does look very interesting.
Yeah, I'll throw one more link in the chat for a place that, or a site that shows what's possible.
All right, and so anybody who I'm not sure who's a student and who's not at this point. I know most of the students are gone, but if there's anybody else on here that wants to pop in and say where you're from, and we'd love to have that, but if not, totally fine. Okay. All right. And then Ken, will you put your email in the chat for Mary?
Yeah, I did. Oops, I sent it just to Shannon. I don't know how that happened. And Shannon already has my email address.
And
Thanks.
Shannon uses it regularly.
Smart people do, right?
Or not so smart people look for smart people to get information.
All right. And Jamie, forgive me, but have you joined us in the past?
Probably for some other things. So I'm a coordinator of therapy at a school for students with multiple disabilities. So I am totally not a maker. But always just look for ideas, and we're definitely like on the using end of the maker stuff, and often have lots of the same issues and struggles with our students. So I'd just like to hear everyone's ideas. So
Well, great. And you know, we absolutely need users. You can't make anything or make anything better without the users and feedback. So my request is always give feedback, because you know, anybody who's figuring things out wants to make it better and better.
right.
That's the kind of the way I think about making is unfortunately you're never done. It's kind of like dishes, you can finish, but there's always something else to do.
Yeah. So I just like to hear what everyone else is, everyone else is thinking about, and see what possible solutions apply for some of our students here. So
Absolutely. Well, thanks for joining us. Okay. Well, it is 9:30, so I suppose if nobody else has anything that they want to share, or any other kind of cool new things, we could probably end today. And all right.
Thanks again for everyone's support and with the students. They are learning a lot from this whole experience.
It's been really interesting. I've had a really good time with it, and I think it was really smart to throw some of these ideas out to the group and kind of get some real world feedback.
I have Naomi to thank for that. So she suggested this. So thank you, Naomi.
All right. Okay, everybody. Well, I guess we will stop our recording and end our meeting for today. And Naomi, do you have the date of the next meeting? December 14th. All right, look at that. Okay. Well, I am gonna save that chat. Okay. Well, thanks everybody. I guess we'll see you next time, if not before.